Hi, I'm Nele Borgert, and today I'll be speaking about a paper that I wrote with Luisa Jansen, Imke Böse, Jennifer Friedauer, Angela Sasse, and Malte Elson, called Self-Efficacy and Security Behavior Results from a Systematic Review of Research Methods. The widespread use of devices with internet connectivity in homes or organizations today raises questions about their effectiveness in maintaining privacy and securing sensitive data. Enhancing security is rooted in the recognition that cybersecurity challenges are twofold, encompassing both complex technological systems and user behavior. The latter is crucial because even the most elaborate technical safeguards become ineffective if they are not used as a designer intended. Therefore, exploring and predicting how individuals engage with, decide upon, and maintain secure online practices is becoming a pivotal area of study. Within this human-centric perspective, cybersecurity self-efficacy stands as the sole framework to reliably forecast an individual's cybersecurity behavior. Cybersecurity self-efficacy is defined as the belief about one's own ability to enact skills related to IT security or privacy. However, the interdisciplinary nature of cybersecurity self-efficacy research has led from a general scarcity of theoretical models to broad construct definitions and heterogeneous theoretical conceptions. This may also obfuscate the true coherence, or lack thereof, of seemingly related concepts and measurement practices, affecting the validity of current interpretations. Hence, we aim to systematically assess the extent of heterogeneity in cybersecurity self-efficacy research methods, with a particular focus on reported self-efficacy measures and their psychometric quality criteria, the role of self-efficacy within its theoretical assumptions, and implemented interventions designed to support cybersecurity self-efficacy. First, we pre-registered our review procedure prior to data collection and trained all three coders. You can access the pre-registration via the link or QR code that led you to our OSF files. We included any empirical research published in English between 2010 and 2021 that included a measure of cybersecurity self-efficacy. Our search string combined self-efficacy with synonymous IT security terms. To combat a potentially biased search string, we relied on a quasi-automated method that uses text mining and keyword co-occurrence networks to suggest further IT security and privacy terms. Here you can see the Prisma flow diagram. In total, all database searches identified 1,769 records of interest. We conducted 3 separate sifts to iteratively implement the predetermined selection criteria, a title, an abstract, and a full text sift. 168 remaining records were eligible and included in the synthesis. 3 coders performed the study selection and data extraction. Each coder was randomly assigned 2 of the 3 blocks. Moreover, we re-randomized all remaining studies after the full text sift, such that each study was coded twice. We reached satisfactory values for both inter-rater agreement coefficients. For interval data, iota was 0.982, and for nominal data, iota was 0.722. The final sample split into 107 journal articles, 39 conference papers, 17 dissertations, 3 conference proceedings, 1 book chapter, and 1 report. Of these publications, 131 were peer-reviewed, 19 were not peer-reviewed, and another 18 publications did not provide information about the review process. Their combined sample size totals over 55,000 study participants. The median age weighted by sample size was 32.98. We also calculated a gender distribution weighted by a sample size of 50% male, 49% female, 0.02% non-binary and 0.21% of the participants did not provide a response. These publications stem from various cultural backgrounds and represent 30 countries. You will find data and code linked in our paper or here via the QR code. When we investigated the current literature about cybersecurity self-efficacy measures, the results paint an incoherent picture due to the sheer number of utilized scales, with more than 170 measures. This figure visualizes the publication rate of measures in relation to studies for the review period under consideration. No consolidation of measures can be observed. Of these 173 unique measures, only 5 were used more than once, and no measure was used more than 3 times. So we found 173 different unique measures of cybersecurity self-efficacy across 174 studies. Of these, 161 measures were first-use measures. In other words, measures that were newly created or adapted for studies without being used prior and without previous validity evidence. On average, scales consisted of a medium item number of 4, ranging between 1 and 54 items. Reliability estimates of first-use scales indicated good coefficients when reported. Weighted by sample size, mean coefficient alpha was 0.868. Scales with repeated use, meaning recurring from prior publication, which we refer to as recurring scales, were similar to first-use scales, with a mean coefficient alpha of 0.871. Reliability analyses for split half or test-retest reliability were not reported. To provide evidence for discriminant and convergent construct validity, studies drew an immense variety of constructs. In total, 330 different constructs were used with the intention to validate cybersecurity self-efficacy scales. Of these, 298 constructs were used for both discriminant and convergent validity. This might reflect a non-consistent understanding of the purpose of demonstrating the convergent and discriminant validity. To identify potentially underlying similarities between scales, we investigated stated references, meaning original authors, for item compositions with the help of a network analysis. The figure shows the directed network graph of who cites who. The results of the centrality measures reveal very little underlying similarities, with a maximal node strength of 10 and a between centrality of 18. The network did not exhibit a small world structure. Regarding the current understanding of the role of self-efficacy, we found that 157 studies treated cybersecurity self-efficacy as a cause of another variable, whereas 67 studies treated it as an outcome of other processes. When consolidating strongly related or nearly identical constructs, we identified 55 distinct outcome constructs, 51 cause constructs, and 19 outcome and cause constructs. We further recoded these constructs to reflect originating theories. Frequencies for outcome variables shown in this figure reveal that no single theory seems to dominate the current literature on cybersecurity self-efficacy. The broad range of non-behavioral cognitive outcomes, categorized as other, underline the diffuse role of cybersecurity self-efficacy in its nomological network. As for cause variables, much research on cybersecurity self-efficacy did not conform with fundamental taxonomy provided by Bandura. Among the studied cause variables were other additional sources of self-efficacy that were of cognitive and socio-demographic nature, such as knowledge, awareness, or age. Bidirectional cause and effect pathways emerge as a relatively frequent phenomenon, demonstrating a diverse interpretation that has not yet been fully integrated into existing theory. Only 13 out of 174 studies included a manipulation of cybersecurity self-efficacy. Generally, implemented interventions were designed to increase rather than decrease self-efficacy. Interventions with activities consider mastery experience as a major source of self-efficacy in this review. We found no replications of any intervention studies. Regarding replicability, 2 out of 13 interventions provided the complete stimulus materials. Thus, we argue that the effectiveness of the identified interventions remains speculative at best. Ultimately, this systematic literature review provides meta-scientific evidence on methodological heterogeneity based on 168 publications. Over the past decade, studies on self-efficacy and IT security have revealed limited use of standardized measurements, models, and intervention methods, which can constrain our ability to draw meaningful conclusions on this subject. Our research is limited by two important types of limitations. Those of evidence and inference, which are mainly shaped by the simple difference between reporting standards and actually performed back-end research processes, and those of implemented review methods, such as the date of data collection and our coding process. However, we hope to raise awareness regarding heterogeneous research practices and aspire to encourage a shift towards greater consistency. Regarding self-efficacy measures, we find it pivotal that researchers ensure transparency, validation, and standardization of measures, such as SIGCHI, a 12-item measure of domain-specific self-efficacy beliefs, which was developed across 5 studies and is based on this review. Please use the QR code to find more details on the scale development process. It is also vital to maintain consistent parsimony and pursue the falsification of self-efficacy theories. Proposition of a new and more complex model is only reasonable when it significantly enriches the theory's explainability and should always be comprehensively justified. And lastly, we recommend that more theory-driven paradigms for interventions should be developed. And in order to obtain robust empirical evidence from these interventions, we recommend replicating the interventions. Thank you for your attention, and please don't hesitate to get in touch with us.